In this video, we're going to have a look at the hydrolysis of esters. There are two ways to hydrolyse an ester, and I'm going to show you a couple of examples of the products that you would form in those reactions. So the first one here with ethyl ethanoate is our reaction with water, a pretty standard hydrolysis reaction. So water involved in the breakdown of this molecule here. Now, what you need for this reaction is you need a dilute acid catalyst for the reaction. So dilute sulfuric acid would do fine here. Now, notice that this reaction is reversible. This is going to be really important in a second. Now, the products that you make, you reform the carboxylic acid, so you get ethanoic acid and the alcohol from which the ester was made. So ethanol is our alcohol. Now, being reversible, this is really important. It means that we're going to get a low yield of our carboxylic acid and our alcohol from this reaction. So because the reaction is moving backwards and forwards, we're not going to get a full 100% yield of these two products. So that's the first key thing, we've got a low yield from that reaction. In our second reaction, we do have an advantage to this. So it is it's a forward reaction where it's not reversible, so we're going to get a much higher yield of our product. But there's still there's still going to be some issues with this particular reaction. So one thing that we don't get, if we are desiring the carboxylic acid, we don't form the carboxylic acid. We actually form the salt of the carboxylic acid. So that will be an issue. So although the reaction is not reversible, we don't necessarily produce the carboxylic acid that we want. We still get the alcohol from this reaction. So if our desired product here was the carboxylic acid, what we'd need to do is we need to add some acid to this. So you'd add a concentrated strong acid, like hydrochloric acid, to drive this reaction forward. And as a result, you'd end up producing the carboxylic acid and the salt of that you'd produce the carboxylic acid again and a salt as our reaction. Now, we'll have a look at another couple of examples here. It's the same reaction going on. So hydrolyzing with a acid catalyst in the reaction, so dilute. Same problem here, our reaction is reversible, but we do get the two products that we want. So we've got propanoate here, so we're going to get our carboxylic acid produced is going to be propanoic acid. And because we've got a phenyl group, the alcohol that we make here is phenol from this reaction. So just remember, reaction is reversible, so we don't get 100% yield. I mean, we wouldn't get 100% yield anyway, but the yield is going to be reduced because the reaction is reversible. That's going to be important to note, actually. Don't confuse that this produces 100% yield of these products. It's not 100% yield, there are other factors that will affect this reaction. If we have a look at this reaction here, again, we're going to produce the salt of the carboxylic acid. So we don't necessarily get the desired product in step one, but the reaction is not reversible and therefore we get a higher yield. Just recall, not 100% yield, just a higher yield. And then we still produce the alcohol here, which is phenol. Same thing would happen if you wanted to turn this into the carboxylic acid. You add hydrochloric acid to it. That produces your carboxylic acid that you desired. And then you get some salt, which you can separate easily from the reaction. Thanks for watching. Please make sure to like and subscribe and keep watching the videos.